Okay, this is chapter 5, section 3, electron configuration and the periodic properties. So, our main idea is we start from characterizing the atomic radius. Atomic radius. Here, I might present one question: why atomic radii or radius of an atom is defined from the perspective of a bond? It says bonded together. Why not? I should take one atom, and let's take any atom X. Why couldn't I measure the distance from the nucleus up to the edge? Why can't I prefer this way of defining an atom? Like radius is defined the distance from the nucleus up to the edge of the atom. This is what we call it atomic radius. But this definition is not applicable. In this way, we cannot apply. Why? In our discussion about quantum mechanical model, electrons are clouds. Electrons are wave, a cloud of electron, and the probability of finding density probability defined by the density probability of electrons. So, if we define electron as a wave, if it is defined by probability density, we are more uncertain to define the age because it is all about probability of finding. So, where is exactly the age of the atom? Here or here or here or here or here? Because it's a kind of cloud. The highest cloud is found near the edge, and less density is found at the edge. So it is very ambiguous to decide the size of an atom by taking one atom. But the best way of measuring an atom is simply the distance between the atomic radius is the distance between the nucleus of one and the nucleus of the other. So the distance between divided by 2, because half the distance between the two nucleus of an atom, we call it atomic radius. This one is better because the probability density of electrons resides in between the atom. So the question here: why is it necessary for the radii of an atom to be expressed as the distance between the nuclei of two identical? Since they are two identical, we divide by 2, so this will be the atomic radius from here in up to here. Atoms bonded together. And as we stated earlier, if we take one atom and we can't exactly know the age of the distance because it is all about probability density of electron. We're dealing with a probability density cloud of electron. So we don't know where exactly the age of the atom. But in taking this one, it's very logical to say the distance, half the distance between the nucleus of the two identical atoms, that will be atomic radius. So together divide the distance by 2. This is the distance. Divide by 2. That's atomic radius. Maybe defined as 1/2 of the distance between the nucleus of identical atoms that are bonded together. So it's better to consider it from bonding concepts, from bonding atoms together. So in this way you can easily so why is it necessary for R to be expressed as? Because describing or defining atomic radius, from a single atom, is difficult because one cannot exactly locate the age of the atom. The age of the atom, because we are dealing with wave. Why it is difficult, the age of the atom? Because this is cloud. Electrons are, so electrons are cloud. Cloud are considered as cloud of electrons. So we cannot exactly locate. So this is why we consider. Okay, when we consider atomic radius, what are the general property across a period and down a group? If we see a periodic table across a period and down a group, across a period, this is across a period, across a period, atomic radius decrease. Why? Why it decreases? The answer is two factors. One, across a period, nuclear charge increase. And the second reason, across a period, electrons are added in the same main energy, These two reasons contributed for the gradual decrease in size of an atom across a period. Why? Let's see. As the nuclear charge increases, let's say this is an atom. As the nuclear charge increases, the attraction force increases. Nuclear charge. So nuclear charge. As nuclear charge increase, this is increase. Attractive force between the nucleus and the electrons. The electrons increase. And the other part, if the electrons added are in the new energy level, the size will be getting bigger and bigger. But now, no size increases, but what is expected, there is electron repulsion there. So, but as you compare the two effects, when the electrons are added in the same shell, electron repulsion increases. And when you add more electron within the same shell without increasing the size, so the effect of nucleus dominate over the repulsive force among electrons. As a result, this effect has a shrinking effect, or it will shrink the size of an atom. That's why we say across a period atomic radius decreases. These are the two contributing factors. Nuclear charge increase across a period, and across a period, this is across a period, electrons are added in the same main energy. As a result, why it grows, the difference in radius between the neighboring atoms in each period grow smaller. The difference is so small because we do have two factors here. One is repulsion, repulsion among electron, and the other is a strong nuclear effect on the electrons. So since the more nuclear effect overwhelm the electron repulsion, so the size increases very small amount and small size. Okay, how about group trend? Uh, Group trend means this one: down a group, down a group, down a group. Atomic radius, atomic radii increase. Why? Why? Why it increase? This is the question. So similar to this one, one is new main energy, main energy appears. So this indicates whenever we have new main energy appears, this means it is getting far. It is the electrons are getting, better to say electrons. So electrons are getting far. The outermost electron is getting far from the nucleus. Yeah, so this is because of new shell. If you see the periodic table, in a periodic table, as you go down a group, the new shells are appearing. So this is 1, 2, 3, 4, 5, 6, 7. So the new shells are appearing, so the size of an atom increases. So if we have an atom, and as you go down, so the size of an atom increases. Even though the nuclear charge increases, this time the increase in size dominates than the effect of nuclear charge. So group trend, down a group, atomic radii increases because new main energy level are included. So, which is barium? So barium is here, strontium, calcium, magnesium. So as you go down the group, the atomic radius increases. And the other important point to characterize an atom is ionization energy. According to this ionization energy, is the energy needed to ionize the atom. So, first of all, in order to ionize an atom, the atom has to lose its electron. So to lose that electron, energy must be paid for that. So let's think across a period. We have already outlined across a period, we have said that atomic radii, what? It decreases. What does it mean? The size of an atom decreases, which means the nucleus is more powerful to strictly attract the electrons towards itself. So removing the electron from this situation is very difficult. So our expectation across a period, ionization energy increases. What does it mean, ionization? Ionization energy, we are referring first ionization energy. We'll come to the second and third ionization. So the first ionization energy across a period increases because why? Why it increases? Why? So size of an atom. So why? Because size of an atom decrease. So what is the relationship between size of an atom and ionization? If the size of an atom, compare this to atom having a small size and this one. So if we have a nucleus, in the case of this one, the nuclear force, the nuclear force strictly attract the electrons. So to remove the electron, more energy is needed. And the opposite. If size of an atom increases, let's say down a group, which means down a group, ionization energy decreases. Why? Again, the size of an atom, because the size of an atom, increases. What implication does increasing size have with ionization energy? If the size of an atom increases, the nuclear force will fail to strictly control or attract the outermost electrons, so the electrons can easily be taken off or snatched by another atom. So the size of an atom increases. So we will continue with regard to removing this thing.